Alright, so here's part one of how to create your own faceplate electronics for your Iron Man helmet. Number one, we have here a 4-gang of AA batteries. It gives you about 5.5 volts to 6 volts, enough to push servos. That's the first part. Second part, for batteries, gang of 8. Once again, it's got the 9-volt connector on top. I'm currently missing those. I need to go buy some more. That gives you about 12 volts. A short strand of wire. This is basically automotive wire, and I'll get to that in a second. Another length of wire. So you're looking to stretch the wire from the top of your helmet down to through your neck seal, across your shoulder, and then down to your hand, which brings us to a push switch. This is a crude push switch. You can trim it down, make it whatever. Basically, we're needing some sort of trigger to start the faceplate activation or the animation for it, and this is what we're using. Next is your Palalo chip. This is a Mini Maestro 6-channel programmable board, and it's pretty cheap. It's 20 bucks. Arduino boards are a little bit more expensive, and this will do what we want relatively cheaply. Next comes the TIP 120 transistor and project lead ends, which will plug into those. You can strip the black shielding off it, solder it, and then reheat shrink wrap them with these. So these are shrink wrap tubes. You're going to need more than that, obviously, but we'll get to that later. Some more leads. So we're talking power for your battery for the lights, power for the servos, power to the board, and then your negative leads for those. 2 HS82 MG servos, middle gear servos. You need middle gear servos. Use plastic, they'll strip. I have a video on YouTube showing you what the non-MG servos do, and they strip. I've done that to about 2 or 3 of them, and I decided, hey, I need Metal Gear. So, not the game, the servo. Alright, so next, Radio Shack resistors. We're looking at 100k ohm, or 100 ohm, quarter watt, and a 2.2 kilo ohm quarter watt resistor as well. And you need one of those, one for the switch, which I'll get to later, and then one for your LED lights, which are here. And what I've done is I've done 2 sets of LEDs per eye. So I've got 3 downward facing, or forward facing, 3 downward facing, and then same thing for the other ones. Once you get that all soldered up, you have your soldering iron, your flux, and your solder. You want to rub it down with some alcohol. Now you can use a brush, whatever. You want to get basically everything off of it. And basically what that'll do is allow you to put Never Wet on top of that. Now what that is a 2-part paint, and it will repel moisture. When I put the chip inside the helmet, it usually goes about right here with a little foam barrier between. And believe it or not, go figure, the inside of the helmet gets very hot. So you're going to be sweating, you're going to be, very hot, everything else. You want your chip to be protected, and that's where you use this. So that's pretty much about it, guys. If you guys have any questions, leave them in the comments down below. I'll be doing a set of these on camera, soldering them. So if you have any questions, let me know. As always, guys, thanks for watching. Subscribe, like, and always do your thing. Alright, so now that we've gone over the components of what's needed to make animatronics and some other things move in our armors, we're going to go ahead and go on to some diagrams and how this thing's all set up. So if you look here, this is basically what the board looks like. And if we pull this board here, you can see that we've got our input-output signals here, or channels. This is the servo power right there. There's 2 ones there. This is the power for the board. You can run between 5 volts to 12 volts for the power for this. And then our first row of connection inputs right here, the first row or 0, is going to be for the switch. That'll tell us when you push the button, open the faceplate. When you push it again, close the faceplate, turn the lights on. The second set the second channel, or number 1, will be for the LED. Number 2 will be for the first servo, and number 3 will be for the second servo. The first and second servos for the last 2. So that being said, this is another. This is how the LED transistor setup is going to be set up. Once again, we have our base, our collector, and our emitter. And if you're looking at the board, let's just say this is the LED. See these 2 circled ones? Those are the ones we're going to be using, the ground and the signal. So what we're doing is from the tip, once again, we've got the signal input being turn the lights on, and then these 2, the collector and the emitter, basically open up the channel between the 2 of those, allows power to flow through to get to the LED strip. The last portion of the electronic setup that we need to do will be for a switch. And if you have the Plolu Maestro Servo Controller User's Guide, it gives you a really nice setup in there. So what you can see here is you've got the 5-volt output from the board, the very last one near the USB connection. What I'm going to do with this is actually I'm going to put in a 1K ohm resistor and then splice that into the wire for the first part that comes off. So this one here, it will be that one there, that connection right there, and basically I'll splice that into that. That'll go off to the switch, and then the other side is the ground. So when you short the connection out with the switch, it says, hey, the button's been pushed. It goes from a let's see, it explains it all in here. Let's see here. Let's see. Wire the button or switch between the signal line and ground so the button is activated. The input will fall below 0 volts. The picture on the right shows how to connect the button switch to channel 1 on the Micro Maestro 6-channel servo controller. So that's what I'll be doing now. So that's the basic wiring setups of how this is set up. I'm going to go ahead and start doing the soldering on this now, and I will be right back. Okay, so here's the first soldering I'm going to go ahead and do on this board. We're going to go ahead and put a little bit of flux on here. And some people say use a brush. I just prefer to get it on the end of the solder. So what we're going to go ahead and do is I'm going to solder this from the, let's see, I'm going to solder it from the back side. I'm going to go ahead and do that. So, oops, small parts, hate them. Okay, flip this around the other way. So what we're looking to do is something along the lines of that. So I'm just going to solder this at the bottom down here. Part fell out. Alright, now we're ready. Okay. And we're just going to go ahead and stuck. Happens sometimes. Alright, let's. Ow. Make sure that's melted in there. Alright, looks like that's a good solder. Let's see, can you see that? Is it going to focus? Probably not. See if I bring it really close. Nope. Well, anyways, it's soldered down. So you can see there's a little bit of solder that came through on the other side. And what we're going to go ahead and do now is actually take a piece of shrink wrap and then place it around the outside edge of that so it doesn't make any contact with anything else. So we have a section, let's see, it's about like that. So we're going to cut that there. I'm just going to go ahead and slide this over the top of this. And bend it. So we have complete coverage of the resistor now. And I'm going to go ahead and heat this up. That's good enough. All right. So now we're looking to splice this connection into another connection. So we're looking at the first connection being the setup for the switch. So we'll go ahead and bend this connection over because we want a low profile board, not something that sticks up that tall. So if you look at that, I just bent the wire over, or the tab connector. So, and then we're going to go ahead and what I'll do is probably just take a little bit of this insulation out and then solder it to that wire there, and then put another shrink tube over that. So let me go ahead and remove that. And this isn't probably the best way to do it, but this is what I do as far as this goes. It's probably easiest. Let's see. Okay. So now I've got a section of wire that's exposed. We're just going to go ahead and solder that up right now. Sorry, there's a lot of off-screen stuff. I have the camera super close to the workspace that I got, just so you guys can see a better view of what's going on. So, all right, so we're going to go ahead and stick that wire in there, and then we're going to go ahead and just wrap this once, and then solder it. Inspect that real quick. That could be better. Okay. Let me do another dab of. This isn't the best soldering iron in the world. Harbor Freight, yay! My welder, the tip broke on it, and I got to order some new tips for my welder. That's a really good soldering iron. This thing is garbage in comparison. So, come on. Oh, it does not want to heat up at all. Come on. knock the fat nodule off the end of the piece of solder because it was taking too long to heat up. Okay, that should be good. So the next portion is going to be setting up the wiring for the switch. And I am using the same color leads. I just ran out of leads, but it'll kind of give you an idea of what needs to be done. I'll go and bend this one over as well. So now these two connections will go out to the switch. So as I said, we got the pull down resistor for the switch, so it's getting 5 volts minus the resistor setting, and then your ground. So when it shorts out, it tells the program to start. At least that's how it's programmed to set up. So next section will be, let's see, the tip 120 soldering or setup. I probably won't solder that one on camera, considering I'm having issues with the soldering iron. So anyways, stay tuned guys, I'll be back shortly. Okay, so here's the second part of the continuation for the Plalu chip assembly. So as you can look here, we have a string of cable, long string of cable, with a push switch attached to the end of it. We have our solder, we have our flux here, so I'm going to dip some of that in there, and our soldering iron here, and our Plalu chip there. So what we're going to go ahead and do now is we're actually going to go ahead and swab a little bit of this flux on here, because you always want to clean your connection, your solder joints beforehand when you're soldering. It just makes for a better connection, and you end up not having any sort of failure points on your solder. So basically what I'm doing is just melting the flux off. You can see the smoke coming off that now. That's basically cleaning the solder joint, and as soon as this heats up enough, I'll start soldering here. I just want to do a little bit of solder, just enough to hold it in place. Too much of a glob of solder would be a bad thing. I usually try to solder it down, or sand it down if I can, depending on how the connection is. But too much solder will cause differences in heat on resistance points and whatnot, and you don't want a lot of solder. Plus it's an extra area of failure. So as you can see here, I'm just cleaning the solder joint here, and then soon enough this will start. There we go. I just want to do a little bit of solder, just enough to keep it held in place, and not too much. So I've already done some of the battery packs. Here's one of the battery packs here, and I've already installed or put in the heat shrink tubing. You want to wrap your connections obviously when you're soldering. Open-ended solder joints on wires will lead to shorts. Whether or not you use electrical tape, which I don't suggest, or you can use heat shrink tubing like that. So that's your basics on soldering. I'm going to go ahead and solder the rest of these portions together, and I'll kind of go over some of them because obviously I've already soldered this resistor here. Let me show you in the frame. This resistor here to the board, that goes into your, let me see here, that goes into the 5 volt out for, I think it's a 100k ohm resistor, and that's for your switch. So basically this is a pull down resistor, so you're applying 5 volts resistor through there, and then you're sending the signal back through the board. So, and I'll do a layup of how these exactly line up. And as you can see here, you got your ground, your power, and the signal for the servos. And I'll explain that in a little bit. I'll be doing a diagram to show you exactly the layout of how I set these up. So So here's the board with the wiring that I've got so far. So as you can see here, I've got the yellow line for the ground, the red one for the power, and that's at the very first row of pin input connections there. We've got our switch with the resistor set up, and we've got the ground for that switch set up. So, and as I said, the power over here. So what we're going to go ahead and do next is the tip 120, and I'll be right back with that. So this portion of the video will be talking about transistors. Now, what we have here is a tip 120 transistor, and what this allows us to do is to run a higher voltage piece of equipment like LEDs or an electric motor that normally can't be ran off of 5 volts. Now, this is a Plala board. It also works with the Arduino as well, and when you're running servos on these channels here, you can only run your 4.5 or 6 volt battery, because anything more will fry the servos. So what we're looking to do is run the 12 volt for the lights and the helmet and some other lights inside the suit. Now, ordinarily you'd say, okay, well, I can't do it, it's not possible, but with the transistor you can. And I'll go over the basics of the transistor here. So what we're talking about as far as connections here, at the very end we have the base, which is what receives the signal from the board to turn on the connections for these two at the end, the middle and the far right. Now, the middle is called the collector, and the one at the end is called the emitter. And so, if you look at this lead, it goes off this way. This is where the LEDs would hook up the negative side. This portion here, as you can see, I stripped the wire at the end there. This will go over to the battery pack on the negative side. So the wiring, I have to solder this still, but the wire will go over to the negative side of the battery terminal. And then, so as I said before, when the signal is sent from the board saying, hey, turn on the lights, it goes through. This is a resistor. That's a 2.2K ohm resistor, and it feeds the power to the tip. And the tip goes, oh, I need to open up the length between here and here, so the power comes in through here and then exits through here. So that pretty much does it for that. I'm going to go ahead and wire up the rest of this. This is a much larger or shorter section of a much larger tutorial on electronics. So for Iron Man helmets and armor, creating animatronic effects and whatnot. So if this helped you guys at all, let me know. Leave your questions or comments down below. And as always, guys, thanks for watching. Share, like, subscribe, and do your thing. Thanks. So now that you've seen how the tip 120 is set up, this is how it looks now. And what we're looking at is let's see how this go. It was the connector, power, ground. Alright, so it goes, let's see, this split one goes into ground, the one that splits off and then breaks off to the power for the 12 volt power source. That one goes into ground here. And then we've got our signal line with the resistor built into it. That goes there. We'll go ahead and pull those over. So now they're bent over, so lower profile. And then the next thing will be the servos. So I've also got to finish soldering up the lights. So I've got my 2 ends there for the lights, and I'll be doing that soon. And then the next step will be mounting it into the helmet. Alright, so now that we got everything together, it looks like a giant jumble of mess wires here, but we'll sort that out when it gets into the helmet. So, let me see here. If we go ahead and short these contacts, lights come on, lights go out. So it looks like everything's good. The next job is to install this into the helmet. Now, ordinarily what I've done is I had one set of batteries for the lights, and then I had 2 packs for these. One to run the board off of, and then one to run the servos off of. This is a specialized helmet. I'll show you in a second. It's the War Machine. I've got the servo all the electronics underneath the mohawk of the helmet. So this may be actually the way I do it in the future. It's one less battery pack. It should be pretty good because it's 12 volt. This is runs off 5 up to 12, and then these run off 12. But these aren't on all the time, so it's and they're very low drainage anyways. So anyways, we'll show you what the inside of the helmet looks like shortly. Alright, so here we have the inside of the helmet. Well, it looks like some sort of crazy cyborg brain. It's a battery pack in the back, top. There's your chip. There's your transistor. This has to be fed down through here. You can see the lights are on down under here. All those crazy funny lights. Gotta hook those up. The thing that I wanted to show you, and I haven't gotten the arms set up yet, so it will throw a little bit when it goes up, but it won't go completely up. Let's see. So I have to fix the adjustment of how far the servos travel, which will be shown next. But you can see it clearly works perfectly good. Lights come back on again. The coolest thing, I think, about this whole thing is that once you screw this thing down, there's 2 screws on the underside. Once you put that on there, you can't see it at all. And it's all self-contained. The only thing that really comes out that does need to go out is the wire for the switch to make the faceplate go up and down. So at some point there'll be a wireless solution for that, but for now this is what I'm going to do, especially for this helmet because there's so much room in it. So stay tuned for the setup and adjustment of the hinges, as well as the programming of some adjustments, and we'll go from there.